Welcome to section 4.6. We are going to be looking at the median of a triangle, and the median of the triangle we'll see is the segment from a vertex to the midpoint of the opposite side, right there. Alright, so title of this is medians. Whoa, not hedians, but medians. Medians of a triangle. There we go. Alright, so first thing we want to know is that this is the balancing point of a triangle. If we take a triangle, let me go ahead and insert a small triangle. I think I have one on paste here. I do. Move it down here. If we are to find the medians of the triangle, we would probably find that if those medians crossed, so let's say that's a median, it's from a vertex to a opposite side, and it cuts the opposite side in half, and then we go to the vertex of this. For some reason it wants to select opposite side here, and it crosses at a midpoint, and we'll find out what the name of that midpoint is in just a minute. Alright, so let's define a median. So it is a, let's see, this is the definition. So a median of a triangle is the segment from a vertex to the midpoint of the opposite side. Alright, so if we have a vertex, let's say right here, come on, let me draw a circle. Do it quick. There we go. Okay, and we find the midpoint of this opposite side. Say the midpoint's right here. The midpoint indicates that this side is congruent or equal to that side. So we can go ahead and draw a line going from this to the midpoint. This line right here is the median itself. Okay, so let's go ahead and make it a little bit thicker. There we go. Alright, so we can take any median over here and do the exact same thing. So let's go ahead and select another color. Let's take this right here. This is a vertex, and we can pick any vertex here. Doesn't matter what type we want, we can pick any of them. So here's a vertex, and we need to find the median. The median would be right in the center, and it is the line that connects these two. So it is, I'll put a little arrow on this one. Goes right there. Okay, so that is the definition of a median. So if you want to try, it could be with any of these three vertex, just one side, drag it over, cuts it in half. Alright, so that is the definition of a median. Okay, so suppose we have a side length of 4 here. this side length is 4. This one is 6. And this one is 5. Where would the midpoint be for this? Well, this would be 2 units, so directly in the middle. So we separate it out into 2 units. So, use a different color. It'd be 2 here. Come on. 2 here. And 2 here. So our midpoint would be probably right about there. Okay? Same thing here. This would be 3. This would be 3. And our midpoint would probably be right about there. Change the thickness on this. There we go. Oh, God. There we go. Alright, now last one we have right here, the midpoint. This would be 2.5, and this side would be 2.5. So we go from this vertex here all the way out to here. So I'll do this by hand, see how well it can do. Not very good. This vertex would have a midpoint over here. So I'm going to go ahead and insert a line rather than make you suffer my poor drawing skills. There we go. And lastly, from the top vertex up here all the way down to that value. Alright. And you notice they cross in the middle. If we didn't have this line, maybe we would want to scoot it down or something like that. It doesn't matter. Crosses at some middle. So we can draw the vertex. So I'll be asking you to draw a few. For instance, try this one. So you can pause the video if you'd like to actually do this. So, wrong letter. Okay. Okay, that's draw the medians of the triangle. There we go. Let's see if I can fix this. There we go. Draw the medians of the triangle. So you can pause it right now, or you can just watch me do it. Okay, so I'll go ahead and do it. There's one right here. There's a side here, a side here. So we can go ahead and take our line and estimate where the middle would be. Probably right there, probably right about there, right about there. And if I give you numbers, you can put the numbers in. Now don't get these mixed up with lines of congruency. So let's insert some lines here. This vertex would go right across here. Oops, move it. Oh, okay. Let's see if I can move it. There we go. Well, close enough. From this vertex down to right about the middle here. And our last line would be from this vertex to the middle here. And I'll try to match it up. Oh, try to match it up as much as possible. There we go. They will all cross. And we'll be talking about that in just a second. So just to note that this right here, if this had a number of like 4, make sure you divide it by 2 to get each side. And if this is like 10, this would be 5, and this would be 5. This was like 7, that would be 3.5, and 3.5. Alright, moving on. So the intersection, this is the intersection. Make sure I get the right one. Intersection of the median. Okay, and what happens is we get a nice little ratio. Okay, so let's go ahead and try to do this as best as possible. We have our triangle here. Let me just adjust a little. There we go. And I'm going to make mine pretty lovely. Thank you very much if you like it. And let's go ahead and mark the medians of it. Let's see. Let's take our line tool here, and we'll just try to do it as best as possible. Go from the vertex to the center. It looks like it has a nice little dot for me already. And lastly, a vertex to the center. Well, generally it's supposed to cross. Maybe we'll just put a nice little, here's the center. Oh, great. Awesome. Awesome possum. There's the center. Okay. So, we go back, draw in the side lengths. These are congruent. These are congruent. And these are congruent as well. And we'll find that there is a nice ratio. So let's call this, this is A. Here is, let's see, B. Here's C. And we'll call this P. And then these points out here, this 1, 2, 3, let's call this E, F, and G. G. Alright, and that's that point right here. I wonder if I can shut that selector thing off. It's really flipping annoying. Alright. Does it do it down here? It does. Maybe I could change it in the writing. Oh, what's going on? Nope. Not even gonna bother with that. Stop it. I'll check on it later. Anyway, it turns out there's a nice ratio that happens. That this side right here, let's go ahead and just take A, P, and G. A, P, and G. It turns out that this can be divided into 3 sections, and these 3 sections are equal. Okay? If you found the midpoint between P and A, it would be exactly the distance as PG. So how does this look like? Well, we write it like this. AP is equal to 2/3 of PG. Okay, so that's one of them. You can do that with this as well, BP. So BP is equal to 2/3 PF. And also we can do that with C and P. So CP is equal to 2/3 of PE. Alright, so what makes that so significant? Well, that if we're given one of the values of, like, say, FP, we are able to find the entire distance. Okay? What is this? Keep current cosine. Don't show this message again. Please don't show this message again. Thank you. Alright. Now, the funny thing is that if we can also write a few other things. AG, the entire thing. Oh my goodness. Remember, that's equal to PG and PA added together. So don't forget that. That's the segment addition postulate. So we'll get to that later. You know, I'm going to go ahead and erase that. Undo, 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 undo. Okay, but we're going to just focus on these. All right. So let's go. Let's go to the next slide, and I'll explain this just a little bit more. All right. So let's see if I can copy all of selecting tool. Alright, command copy. We're going to delete this one and paste. Oh, looky, that looks great. Alright, so we have our triangle here. And let's say the value of EP, so here's a problem. The value of EP EP equals, let's say, 6. Alright? EP is equal to 6. Suppose we wanted to find PC and CE, which are the entire which is the entire segment. So this is the entire segment. All right. Well, this value, let me go ahead and write it in, is 6. Oh, God. Is 6. So we have to figure out this value. Now, it says PC is 2/3 bigger, okay, than PE, which means that that 6 is like 1/3, and therefore we have 2 of them. So we should have some sort of nice ratio, right? Nice number here. So if we want to write out our equation, it turns out to be CP equals 2/3 PE, which is 6. Alright, so let's figure this out. CP is equal to that. Okay. And we plug the value in, and we end up getting CP equals, let's see, 12, 24? That can't be right. Hold on a second. Where did I screw up? Oh no. Oh no. Dang, I want to go back. It turns out this is not PG, this is something else. So let me rewrite this whole thing right here, see if I can just select this. Nope, I get it all. Great. Okay, let me try this one more time. So this is for the intersection of the medians. And it turns out that its CP is equal to 2/3 of CE, of the entire thing. And same thing here, we have FB, 2/3 of FB is equal to PB. Okay, we can also say that 1/3 of our entire thing, so let's do the other one, AG, 1/3 of AG is equal to PG. Okay, so this is 1/3 of the entire line. And we can keep looking at these. It's going to be 1/3 of CE is equal to PE. And also 1/3 of FB is equal to FP. So these are our 1/3 ones. And our 2/3 ones, well, they're almost complete. We're missing AG. So we say that AP is equal to 2/3 of AG. So we go back, go to our next slide here, and it says find EP. So we're going to go ahead and find EP. Now we're going to use our equation here, not this one. So I'm going to cross this one out. It's not the one we use. We're going to be using, well, first off, we want to find out what PC is. Now, if this is 6 And this is 2/3. That means this is 1/3, which each part is a whole. So PC equals 2 of the PE. Okay? And you can write that on here as well. We can say, let me get a marker here. PE times 2 is equal to CP. And same with 2 of the FPs equal PB. That didn't go. And then also 2 of the PGs equal the PA. Okay, so this is half of the entire thing here. So you can put a box around that one as well. Alright, so we go back here. Here's our lovely thing we got going on. Remember this right here. And we will go ahead and move on. We know what PE is, which is 6. So CP or PC is 2 times 6. So CP equals 12. So the entire distance CE, we could just take 12 and add it to 6. That will find it. So CE equals 12 plus 6, which equals 18. So we have our two values here. Alright, let's try another one, because that was a little bit confusing. Okay, here is your triangle. Let's go ahead and delete this one. And I'm going to go ahead and just draw in all the information. Let's go with here. Whoops. Undo. So start at the vertex and go down. Start at the vertex, go to the middle, start at the vertex, go to the middle, should cross that. Well, it was close. Make it nice and, there we go. Alright, so we'll call this A, B, C, D, E, F, and G. Alright, and let's have you find AD and GD if AG equals, let's make it 18. Okay, so if you want to pause it, you're welcome to. Go ahead and pause, and I will be here when you come back. Hello, welcome back. Here is the answer. First, let's go ahead and do, let's see, let's find GD first. We know that AG equals 2 of the GDs. Okay, that was just the last slide. So let's go ahead and plug this value in, substitute 18 into AG. So we get 18 equals 2GD, divide by 2, and we end up getting 9 equals GD. Hey, there's 1. So let's go ahead and label it. It's always good to label. So this is 9. This is 18. So we should be able to find the entire distance. 9, 18, that's 27. 9 plus 18 equals 27. And that equals, of course, AD. And that's what the problem asked. Alright, let's look at, let's see, one more. Let's make it green this time. Draw our medians. There we go. And let's call this, start with the letter R. R, S, T, U, V, W, and our center is X. Okay, so let's say we know that Wx equals 5, and we also know that xv equals 8. Let's find Wt and Vs. Okay, if you want to pause it, go ahead and do that. Here, let's see the answers. Here's Wt. Wt is the entire thing, and Wt equals Wx if that is 1/3. So 1/3 of Wt equals Wx. Hey, alright, so we now have 1/3 Wt equals, let's plug in 5 over here. Oops, cut that one in half. 5. So how do we get rid of fractions? We multiply what's on the bottom. So we multiply this side by 3 and this side by 3, and we end up getting Wt equals 5, 10, 15. Oop, there's our first one. How about SV? So we have SV, the entire thing. We are given XV, which is 8. Okay? And yes, they don't have to be the same. They're not equal. Okay? So this is the longer side, so this is 2/3 of the entire thing, Vs, equals 8, or equals Vx. So we're going to plug in 8 here. I'll change the font. Plug in 8 here. We end up getting 2/3 Vs equals 8. Okay, we're going to multiply both sides by 3 to cancel these out. We end up getting 8, 16, 24. So let's move this over here. We get 24, and that is set equal to now 2 Vs. So divide by 2, and we end up getting Vs is equal to a total of 12. And we have our answer. Alright, so maybe you could work on a few of these. If you want, you can go back and look at any of these slides. Let me go ahead and delete this. Where's the delete button? Oh my god, okay. Now, your homework that we will be looking at in class when you come back, and we'll be doing in class because that's how it's going. It's on page 209, and it's going to go till, let's go till 211. And if you don't do this, we'll have time in class. I mean, if you don't have your book, you should be doing it at home, but if you don't have your book, then you'll have some time in class to do it, but I expect some people to do it. I want you to do number 4 through 16. And here's a little bit of review. 24 through 29. So that would be fantastic if you could get that finished. And as a parting gift,